Every time that I think about the things that I have been studying in my life, I know I will never have all the answers. Because science is always changing, always having new visions about the things that are around us. And it is science. Science is more about what the things are in our vision, how we describe them till we understand them, not how the things really are. We expect to put our concepts about living things in boxes and hope that all these things will be as we describe them. In biology, the exception is the rule. Every single time that a scientist writes a rule, a theory, a statement, it's possible that something is running out of this. And it happens almost all the time. So, it's not just read a line and repeat it the entire life, but understand it and can write an entire page about that, and in some points writing things against that idea, not just with your opinion, but with your knowledge. Now, it sounds confused, but don't worry, I'm doing this and another videos to talk to you about it. So, let's begin. I'm a biologist, and despite the biology be the field of knowledge which studies life, bio, life, log, study. Me and other biologists don't know everything about life. In fact, you need to choose an area of research and after this a subjective inside this area and study about it. Today, it's what we have. Every one of us is becoming more specialist in something, looking just to a single point of life and, almost of the time, forgetting the other things. In ancient times, if you were a biologist, you needed to know about all living things, from the amoebas and to the whales. We must consider in that time it was possible. The knowledge accumulated was not so big as in currently days. After 1800s, the amount of knowledge increased so much that it became almost impossible to embrace everything. Well, I'm saying it because I chose to study mammals when I was 10. Yes, believe in me, 10 years old. But just in my graduation, I learned that I needed to pick up a group, or just 2 or 3, and use my time in these groups. You always will know better about one group, and the others not so much. I always loved the marsupials, which is not a real order, but now I know more about deers and elephants. Now, let's talk briefly about deers, for example. The important thing is make questions. If I will study deer, so what's a deer? A deer is a mammal. And what's a mammal? It's a vertebrate animal. What's an animal? It's a kind of life. As a biologist is the professional that studies life, of course they know what's life, right? Not exactly. The materialism is the first idea about what life is. The principle says that the matter is the fundamental substance in nature. When different amount of the elements are put together, they become different things. One of the first persons that to write about what life is was Empedocles, a Greek that lived between 494 and 434 before Common Era. He argued that everything in the universe was formed by the different combinations of the 4 basic elements: earth, air, water, and fire. Of course, he was not talking about life itself, but the idea of the all things is formed by the same things, what is now called atoms. But that just explains what life is made of, not what it is. What made a set of atoms be life? According to another Greek, Democritus, which lived between 460 and 370 before Common Era, the essential characteristic of a living thing is having a soul, which he explained is formed basically for fire atoms, making a connection between life and health. It just explains what makes something a living thing, not what it is in fact. However, it's a point when we put the living things in one side and the unliving things in another. He knew that there was something different between a living thing, a man for example, and a stone. Today it's obvious, but in that time didn't. We just have the currently knowledge because someone has an idea and wrote it. So other person read it, thought about it, and gave a step forward. Because basic science is important. After materialism, we have the illomorphism. Still in Greece, Aristotle, which lived between 384 and 322 before Common Era, believed that all universe was made of matter and form, and the form of living things is soul. To him, there were three kinds of soul: plant soul, which cause nourish and growing; animal soul, which cause movement and feel; and the rational soul, which is the source of consciousness and reasoning. We can see at this point, the people believe that the living things are separate in three types: plants, animals, and humans. It's important to say those people are not really biologists, but philosophers, so their vision about living things is philosophical, not scientific as we know today. Aristotle also is responsible to the idea of spontaneous generation. He believed that living things can appear from inanimate matter, like rats, fleas, and mice arising from mud and garbage. This idea was a true statement until 1668, yes, almost 200 years, when the Italian Francesco REDI made a simple experiment that proves which living things cannot arise from inanimate matter, or be created by spontaneous generation. To resume all the experiment, what he did was took two jars and put a piece of meat inside, covered one and left the another uncovered. He saw that in the jar uncovered, there were some flies above the piece of meat. What doesn't happen in the jar with cover. After some days, he covered the one that was without cover. After some time, some maggots start to arise from the piece of meat on the jar that is the first experiment was without cover. What didn't happen in that was always covered. He took these maggots and waited for the metamorphosis, and they becoming flies. Again, he took two jars with a piece of meat, putting in one living flies and in another dead flies. The maggots just appeared in which was living flies. According with this experiment, Francesco REDI saw that the living things doesn't arise by inanimate matter. In the 17th century, the vitalism was originated with the German Georg Ernst Stahl, believing that there was a fundamental difference between inorganic and organic things, because he believed that organic material just comes from organic material. But In 1828, another German, Friedrich Wöhler, disproved this idea, producing urea, an organic material from inorganic material, and it is considered the start to the modern organic chemistry. That's the fundamental science to will understand what life is. Even after almost 2 centuries of organic chemistry, we don't have a perfect definition to life, because, in fact, life is not a substance, but a process. However, we can point some principles about life. Homeostasis is the ability of the organism to keep your internal environment in spite of the external environment, like the polar bears on North Pole or the camels on desert. They live in totally different habitats, but they are mammals and can keep your organisms working almost in the same internal temperature. Organization is the structure formed by one or more cells, the basic unit of life. As we know, there are a vast number of organisms that are formed just by one cell, and they are very different each other, and the same happens with the multicellular organisms. Metabolism is the capacity of the organism to process chemical and energy to the cells, which we call anabolism, and decomposing organic matter, which we call catabolism. This energy is vital to maintain the homeostasis and keep the organism alive. Growth. The organism needs to keep the anabolism higher than catabolism to grow up, or it will consume itself. Adaptation is the ability of the organism to change in response to the environment to keep itself alive. It's not evolution, which will be discussed in future videos. Here, the organism already has the tools to respond to the environment. Response to stimuli is the capacity of the organism to react from external stimulus, like when some organism is touched and it contracts itself. It's a mechanical response, but there are chemical responses too. Like when some organisms are touched, they release some substance to protect itself. Reproduction. The ability of the organism produces new individual organisms by sexual or asexual process. So far, so good. But we have viruses. And what a virus is? Is it life? In fact, because viruses exist, we don't have a clear definition what life is, because they present most of the principles described before, but in some of them they don't. Sometimes they are called the replicators. As they are microscopic organisms, we don't know about their evolution. They lack reproduction mechanism and metabolism. But there's a thing called the evolution, and according to this theory, the organisms changing along the time, but with no direction, no purpose. So maybe a virus once was an organism with reproduction mechanism and metabolism, but to it survives, instead they waste its energy, reproducing itself and producing energy to itself. Is more efficient left to the other organisms, replicate them, and use their energy of metabolism. And as I said, in biology, the exception is the rule. I think the viruses are the exception, but I want you to think about it. My definition of life is a replicable chemical system which struggle against the entropy and evolve. Another hard question to answer is how the life appears. Again, we don't have historical record about it, but we have some evidences of biological waste that are dated from 3.5 billion years ago. The Earth has between 4.5 and 4.6 billion years. We can remember that when something appears, it's just a sample of this. So it left a geological record takes some time. So, when we found a record of something, probably it's older than it. There are studies that show it could be water on Earth at 4.2 4.4 billion years ago, and life could be existed between 3.8 and 4.2 billion years ago. We can think about panspermia, but it doesn't resolve the problem. How life arises just change the problem from another place in universe. Being the cell the basic unit of life, scientists try to clarify how the molecules joined each other and become cells. At first, we need to know that all matter in universe is made by atoms, which are made basically by electrons, protons, and neutrons. With these three components, it's possible to create all things, all elements on periodic table. If the ingredients are all there, why not? But how it did happen? What events help to these ingredients interact with each other and create more complex molecules? In 1922, the Soviet biochemist Alexander Oparin made some statements about how life began. There is no fundamental difference between a living organism and lifeless matter. The complex combination of manifestations and properties characteristics of life must have arisen as a part of the processes of the evolution of matter. Taking into account the recent discovery of methane in the atmosphere of Jupiter and the other giant planets, we can suggest that the infant Earth had possessed a strongly reducing atmosphere, containing methane, ammonia, hydrogen, and water vapor, which were probably the raw material for the evolution of life. There were first only simple solutions of organic matter, the behavior of which is governed by the properties of their component atoms and the arrangement of these atoms into a molecular structure. Gradually taught, the resulting growth and increased complexity of molecules brought new properties into being, and a new colloidal chemical order developed as a successor to more simple relationship between and among organic chemicals. These newer properties were determined by the interactions of these more complex molecules. This process brought biological orderings into prominence, like competition, speed of cell growth, survival of the fittest, struggle for the existence, and, finally, natural selection determined the form of material organization characteristics of modern-day living things. Oparin was the first scientist to talk about the primordial soup. But in 1929, the English J.B.S. HALDANE introduced the modern concept of abiogenesis, describing the primitive ocean as a vast chemical laboratory, a hot dilute soup. When we mixed the organic with inorganic compounds. Under the solar energy, the anoxic atmosphere contained carbon dioxide. Ammonia and water vapor gave rise to a variety of organic compounds, living or half-living things. the first molecules reacted with one another, producing more complex compounds, and ultimately the cellular components. At the time, some kind of oil was produced, enclosing some self-replicating nucleic acids become the first cells. In 1952, the Americans Stanley Miller and Harold Urey made the famous experiment named Miller-Urey experiment. It consists in two glass flasks connected by tubes, one with 5-liter capacity and the other with 500 milliliters. Inside of the big one are two electrodes. The experiment begins putting water, methane, ammonia, and hydrogen in the small flask and heated it to induce evaporation. The water vapor enters to the big flask and there receives electrosparks, simulating lightning. So this vapor is cooled and returns to the original flask like water again. After a week, the solution is red and turbid. To prevent microbial contamination, mercuric chloride is added, and to stop the reaction is added barium hydroxide and sulfuric acid. The solution is evaporated to remove impurities. Using a paper chromatography, it's possible to identify glycine, alpha and beta alanine, and maybe aspartic acid and alpha aminobutyric acid. We need to keep in mind that, in fact, there is no such thing of inorganic or organic matter, because it is a convention. All that we describe must be according to the conventions that all of the scientists agree. So every compound that is carbon-based compound is called organic matter. It's just it, a convention. Maybe it could be possible that some kind of organism can arise without carbon, and even that we call life. So it's more about what we will say what life is. This video was an introduction. In the next video, we talk about the classification of life. See you.